Okay, so let's look at problem 1122. Let me read out the problem. A motorcycle accelerates to 600 RPM in 5 seconds and then it is braked to a stop in 2 seconds. Calculate the total number of revolutions. Okay. It's similar to the previous problem where there are 2 stages. So a motorcycle accelerates to 600 RPM. Here what is indirectly said is it accelerates from 0 to 600 RPM. So let's do the same thing. So omega naught is 0, omega 1 is 600 RPM. Okay. In 5 seconds. Yes, in 5 seconds. Okay. And then in the second stage it is braked from omega 1 is equal to 600 RPM to omega 2 is equal to 0 RPM in t is equal to what was it, 2 seconds? Yes, 2 seconds. 2 seconds. Okay. Alright. So and we need to find the total number of revolutions, right? Angular displacement. So what we do is we find theta 1 from here, we find theta 1 from here, and then we find theta 2 from here, and then add them both just like last time, right? Unfortunately, just given initial final velocity and time, we cannot find theta. So to find theta, we first need to find the acceleration. Okay. Once we have acceleration, then we can find theta. So maybe a proper diagram might be like this. From here we find the acceleration, then we use the formula s equals ut plus half at square, the angular equivalent of that, theta equals omega naught t plus half alpha t squared to get theta. Same thing here, right? And then we add it up. Okay, so let's go about it. I'm going to call this stage 1. Okay. All right, so for stage 1, again, before we do that, we gotta convert this to RPM to radians. So that is 600 times 2 pi over 60, and that's equal to 62.83 rad per second. And then that's it. So here also it is the same thing, 62.83 rads per sec. Okay. Alright, so let's go ahead and use the formula. First find acceleration. Acceleration is final velocity, which is in this case final velocity is 62.83 minus initial was 0 divided by time 5 seconds. So that comes to what, let's see, 12.6 radians per second square. That's the acceleration 1. From here we can calculate theta 1. Theta 1 is initial velocity, which is 0. Let me write the formula. Yes. Okay. Omega naught t plus half ut plus half alpha t square. You want to call it t. Okay. Omega naught, the initial velocity was 0 plus half alpha 1. We just found 12.6 t squared. T is 5 square. Okay, so that comes to 157.5 radians. Okay. All right. Now we go to stage 2. Okay. Maybe we want to change the colors. Stage 2. Okay, here we're decelerating, so alpha would come out negative, so final velocity is 0 minus initial velocity, angular velocity, is 62.83 divided by, here it takes only 2 seconds to do it, so negative 31.415, so let's leave it at 31.4. okay, radians per second square. Right now, same thing, we take theta equals omega, here 1t initial velocity, half alpha 2 t2 square, so this is t2. Okay, 1 because this is the initial, right? So here the initial velocity we're calling omega 1, here the final velocity was omega 1. Okay, like I said, as long as you can keep it square, it's not a big deal what terminology. You can simply say theta equals without any subscripts also. Like I said, I'll overlook it as long as these substitutions are right. If the substitutions are right, then I know that in your mind you know what is initial final velocity. Okay, so this is 62.83, that's the initial velocity for the second stage, times 2 plus half alpha is negative here, 31.4 t2 square, so 2 square. Okay, what does that come down to? Theta 2 is 62.86. okay, 62.86 radians. Okay, all we need to do now is take this number, add them up, so you get what do you get? So theta is theta 1 plus theta 2 is what, 157.5 plus 62.86, so that comes to what, you get, you have 6 3 1 0 2 2, right, 220.36 radians. If you want to get in revolutions, which we prefer, so multiply radians, so we say radians here, 2 pi radians is 1 rev, so radians cancel out, so 220.36 divided by 2 pi comes to about 35 revolutions.